Okay, so a couple reminders. Albert I.O. is due every Monday. We have 9.1, I'll write it up here, Tim. 9.1 quiz is Friday. We'll do a quiz review tomorrow, learning the last part of 9.1 today. And homework check tomorrow. Okay. Don't forget about Albert I.O., the easiest points that you can earn in this class. Nice way of keeping your grade, the homework grade, nice and high. Okay, so I want to remind you what we've been doing this week. We started on Monday practicing factoring. Remember, we did that worksheet. We went over all the different types of factoring, and we just practiced that, reviewed that, okay? And I made it pretty clear to you that you have to know how to factor to get through this whole chapter. It's all factoring. Every single day we have to factor, okay? So you can't ignore that. You can't just skip over it. You're going to have to be able to factor. So remember, there's a video, there's good notes, lots of practice problems, and I'm reviewing it within our new material because, like I said, it's the first step in all these problems. So yesterday, we started rational. Oh my gosh, I wrote radical yesterday. That should have been rational. I don't think you care too much, but it bothers me. They're rational functions, not radicals. There's no radicals in these at all. Did anybody think that was weird yesterday? Is anybody wondering about that? I don't know. But sorry, I don't know why I wrote radical. These are called rational functions. And remember, it's a polynomial on top and a polynomial on bottom. So looking at what we were looking at yesterday, we would be given something to factor on top and something to factor on the bottom. And we factored and canceled out identical twin factors. Okay, so we did those. You guys did really well with them. And we would simplify and get a simplified rational just by factoring and canceling anything that was identical. That's what we're doing today, too. Guys, let's put our phone. Evan, come on. You guys, you need to not be on your phones while I'm teaching. It's really, really not good for your math health, okay? My mental health. It's not good for my, I don't want to be responsible for me being depressed or anything, right? Okay, so what we're doing now is multiplying and dividing them. So what I want you to notice this first one is, it's two rational functions. So yesterday we were just given one and we simplified it, right? We were just given one and we simplified it and canceled. Well, now we have two of them and we're going to multiply them together. The way we do it is, I call these the four corners, just to make it easy. Four corners. You factor any of the four corners that you can. So you might have to factor 4 times. Usually not. Like this top left corner, there's nothing to factor, right? It's just n plus 8. But we can factor this. This is a chart problem. We can factor this top one here because it's a GCF problem, what they have in common, and there's nothing to do here. So when you get a multiplication problem, you look at all 4 corners and you decide, is there anything I can factor? And you do that first, okay? So, like I said, we're going to do the chart here. So I'm asking myself, what two numbers multiply and add? For the multiplication, it's 1 times negative 27 and b value of negative 6. And 27 has 1 and 27 or 9 and 3. 9 times 3 does give us 27, and I know I can subtract those and get a 6. But how do I get a negative 6? Play with it with your calculator in your head, whatever you need to do, but you should know that the 9 would be negative. Make sure it works on this side as well, okay? And is this the short or the long factoring? Short. What tells us it's short, Dylan? Yeah, well, there is a number. What's the number? It's a 1. Very good, Dylan. That's a 1. Whenever this is a 1, we get to go right to our factored answer. And I'm just going to write it right here. N minus 9, N plus 3. So that's my new denominator here, right? Let's go over to the second fraction. We already talked about we can't do anything to the denominator, but we can factor the numerator. What do 5 and 15 have in common? 5. So I'm going to factor a 5 out. How about n's? Can we take any n's away from them? Take one n. Ooh, I got an expert factor in the front row. 5n. Yes. So when I divide this guy by 5n, I have n left over. Divide that guy by 5n, I get 3. You can check that really easily by doing the distributive property. Okay? And I can't do anything to this denominator. Now you can leave it just like this, and I'll show you how to write it one other way if this is hard for you to understand the way it's written. But what we're going to be doing right here, guys, is finding anything that can cancel. Where you can cancel is up and down, just like yesterday. But look, there's nothing there we can cancel. Or diagonal. You can cancel from here to here or here to here. The only way you can't cancel is side to side. So if there was like an n plus 3 in this denominator and an n plus 3 in this denominator, you cannot cancel them. Up and down or diagonal. Okay, now I'm just going to write this, and this is optional. In case this is like kind of messy for you to look at, I could have rewritten it as n plus 8 over n minus 9 n plus 3. See how I'm just like getting rid of the crossed out piece? Okay, so this green stuff is optional. You could absolutely have left it the way it was, but maybe this is clearer for you, okay? You decide, that's your choice, okay? So I'll simplify both forms of this. So like I said, we can simplify, cancel anything up and down or diagonal. So is there anything up and down? Oh yeah, look, 5n and 5n, excuse me, cancel. Right? 5n and 5n cancel. Anything else cancel? N plus 3 and n plus 3. Maybe it's easier to look at it here. Look, 5n's cancel, n plus 3's cancel. What am I left with? Whatever I didn't cross out goes in my final answer. So I have n plus 8 on top and n minus 9 in parentheses, n minus 9 on the bottom. I lost the parentheses because I'm not multiplying by anything. I mean, would I mark it wrong if you put parentheses around the n minus 9? No, not at all. Okay, but that would be your final simplified answer. So you don't really actually multiply, okay? Even though it says to, our answer is going to be in multiplied form, like anything that's left is being like multiplied, but you don't actually have to like multiply these big polynomials together. Division is almost exactly like multiplication except one little step. Whenever we divide with fractions, we have to remember there's a first step that we have to do before we can do anything else, okay? Which is to get rid of the division. Division of fractions, do you remember what that stands for? Keep, change, flip. Keep, change, flip. I think of KFC, but the letters are messed up, right? Keep, change, flip. So that's the first step. I'm going to rewrite this. Keep the first fraction. That's what keep means. Keep it. Don't do anything to it. That's keep. Change means change division to multiplication. That's the change part. Flip literally means flip this fraction. Now, my darlings, this problem is just like the one we did above. Factor any of the four corners that you can, then cancel anything up and down or diagonal. So when I look at my first fraction, that's x plus 7 over x minus 5. Can I factor either one of those? Nope, there's nothing I can do with those. Yay, we love it when that happens. Okay, my numerator is a short chart problem, right? So I'm just going to find some space to make my chart. 1 times 15 is 15. B, that middle term, is negative 8. Don't forget to take a negative with the number, okay? If there's a negative in front of a number, it goes with the number, okay? And then 15 is either 1 and 15 or 3 and 5. Well, 3 and 5, I know I can make an 8 out of that somehow. How do I make a negative 8 with a 3 and a 5? Both negative. Good. If you do a negative 3 times a negative 5, you get negative 8. Check it over here. Negative 3 times negative 5 is positive 15. If you're not good with your negatives and positives, pick up your calculator. You're allowed to use your calculator. Okay? So this is going to become x minus 3 and x minus 5. Does it matter which set of parentheses goes first? Not at all. Okay? Can I do anything with x squared minus 9? Yeah, that's the difference of two squares. These are the easiest ones to factor if you just recognize that it is that one. Remember, we have two parentheses, two different signs, always. And then what's the square root of x squared? Just x goes in the front. And the square root of 9 is 3, goes in the back. So the parentheses are identical, except one's a plus and one's a minus. Doesn't matter which one goes first or second. Okay? Now, just for those of you that have trouble with all that muddled mess, I'm going to rewrite it, but this is completely optional. I'm just, for teaching purposes, I wouldn't necessarily rewrite all of this, but it sometimes helps people see what we're looking at here. So this purple step is optional. Okay, so you can cancel anything up and down or diagonal, okay? X minus 5. Yep, we can definitely cancel this x minus 5 with this x minus 5. Is there anything else? X minus 3 and x minus 3. Nothing else can be canceled. Whatever's left is your final answer. So there's an x plus 7 on top and an x plus 3 on the bottom. So like I said, if you can factor, this is cake, because the actual steps in the math are not the difficult part. So you guys pulled out 121 yesterday. We're on the back of that paper, so wherever your homework sheet was from yesterday. And I'm going to give you two changes to make. Just to simplify it for you. So make those changes, and then I'll do the first one with you. As you have a homework check tomorrow, you only have 4 homework problems to do today. Yeah. Oh, I thought I froze it. I'm sorry. I thought I froze it. So sorry. Would you mind getting the door? Thank you so much. Oh, I thought there was one there. What? Oh, they haven't made the rule yet. That was a real one. No, they haven't made. In fact, I asked Officer Kamini about it. He's like, I've never even heard that rule. So I forwarded him the email I got about it, and he's looking into it. But the one rule they are enforcing is keeping the door closed at all times, like at lunch and everything. But the other one, not yet. Okay, so you made those two changes to the problems. Let's do 24 together. First thing I notice is 24 has multiplication in it, so I don't do keep, change, flip. I just start factoring, okay? So go to all four corners and see if there's anything you can do. So in both of my numerators, those are chart problems. Second denominator is a difference of squares, okay? We have to be good at these chart problems. They come around a lot, okay? So y squared plus 8y plus 15. And I don't have to see this, especially on a plus-plus problem. All of your signs are going to be positive in a plus-plus problem, and maybe you can come up with your numbers for 15 and 8 without a chart. That's totally fine with me. Okay, I don't have to see this. I mean, I don't draw a chart when I do these. I can do it in my head, and maybe some of you are getting to that point as well. Right? The two numbers that multiply to get 15 and add to get 8 are 3 and 5. So this numerator would be y plus 3 and y plus 5. Okay, can't do anything to y minus 6. Let's move on. I will have I'm just going to use this space over here. I'll do a chart for this one. 18 and negative 9. 18 has a few factors, right? 1 and 18, 9 and 2. What else? 6 and 3. 6 and 3 make a 9. But we need a negative 9, so we make them both negative. As you might be noticing, anytime your polynomial has a minus, then a plus, that order, every single time, they're both going to be negative. It will always happen like that. Just like when it's a plus and a plus, they're both positive. And down in the bottom right, that's the difference of squares. 2 parentheses, 2 different signs. Square root of y squared goes in the front. Square root of 9 goes in the back. And you can rewrite it if you want to. I'm going to start canceling now. And it doesn't matter where you start. Just look for anything that's up and down or diagonal. Do we see anything? Sorry, I already started with this one. I'll come back to that. Y minus 3, or 6, right? Cancels with y minus 6. Y plus 3, yep, that one can cancel with this one. Isn't it really satisfying to cross these out? I love it. Y minus 3 cancels with y minus 3. What's left? Y plus 5. So you want to be neat. You can see, you guys know I can be a little messy. I can start going really fast. I'm being really careful because when you have all these lines in your problem, especially if I didn't write it again, you want to be able to easily see what's left, right? That's all that's left after I cross everything out. And I'm very careful about being clear about what I cross out. I don't want to miss something in my final answer. Okay? Right, again, you have 3 left to do, and I'm showing the answers, not the work. So you need to do exactly what I just did in the examples in the homework problems that I did. I showed a little bit of work on 27 over there. We will review both days tomorrow and quiz on this stuff on Friday. Watch the factoring video if you're still struggling, please. Gotta practice, 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 practice.